Hey guys, so before we start, I just want to let you know that this tutorial is part of a significantly larger and comprehensive course on JavaFX that I've created. It's available in the link below on Udemy. But a quick disclaimer, you don't need to go through that course in order to understand what we're going to do in this section. Everything that we do here is standalone and you can learn it on its own. That's why I'm uploading it here. But if you want to help out, do check it below. There's also a discount, which is neat. So see you next. All right, and welcome back. In this section, we're going to talk about concurrency. So every time you write an application or every time you create an application in JavaFX, you will most certainly need an ability to run certain tasks on the side. So remember that in JavaFX, you have this main thread known as the JavaFX application thread. And this is where, on this thread, this is where our scene graph lies, and any updates, any methods, any events that you call or that you handle must happen on this thread, right? So in other words, when you update the scene graph, you must do it on this particular thread. But there comes a time when you need something else, right? So for example, there'll come a time when you need to connect to a database, for example, or you need to connect to a remote network. This requires a separate thread. In Java, there's a concurrency framework that you can use to create separate threads so that you have sort of different processes running simultaneously. JavaFX adds on that. So essentially, the JavaFX concurrency framework is built on top of the Java concurrency framework. It's small, but it is obviously tailored towards graphical user interfaces, and this is exactly what we're going to look at in this section. Hello and welcome back. Now I want to demonstrate what I meant by JavaFX essentially having one JavaFX main thread and the problems that can arise when you try to run some long running task on that thread, right? So we have our simple application. We have a VBox, root, and alignment, spacing of 10, and the simple application we usually start with. So I'll create one button and then I'll call it, let's say, button. I'll call this, let's say, stop UI, right? Stop UI, and that's exactly what it will say, right? This is the long running task that stops the user interface. Then I'll also create another button that says called an exit button, and it should say exit, right? Suppose the user wants to exit the application. So we can do on the stop UI, we can do .set action, an action event, and what I want to do is start with a try. So what we're going to do is essentially stop the thread, right? Say thread dot sleep, and I want to give it 10,000 milliseconds, or should be around 10 seconds. So that should be long enough. But in real world applications, you might have a task that's running for 10 minutes, right? You don't want to have the UI freeze for 10 minutes. At that point, the user will assume the application has just crashed, even though it hasn't. It's just bad programming. All right, so we just print it start trace if there's a problem, and on the exit, I want to do set action. So I'll do it's an action event, and I'll do platform dot exit. All right, perfect. And of course I need to add our children to the root, so we'll have stop UI and then exit, right? So let's run the application. All right, so first I want to exit without stopping the UI, see how responsive it is, right? If I do that, the application exits perfectly. Now let's rerun it again, and this time stop the UI and immediately try to click the exit button. So if I do stop user interface, if I try to click the exit button, nothing happens. I have to wait 10 seconds for the exit button to be executed. All right, so as you can see, the exit button is executed. So the event is actually recorded. It is just added to the stack, right? So or the stack or the queue, for example. So it is added to the queue, and it waits until the first method or the first event has been handled, which is the stop UI. After it is frozen for 10 seconds, it goes on to the next event in the list, which is the exit command. All right, so this demonstrates kind of problems we have, and we'll solve this by making sure that these long running tasks are handled separately, right? They're handled on a separate thread. If you're opening large files, if you're connecting to a database, if you're connecting to a remote server on the internet, whatever it is that might take, not necessarily always, but might take, depending on who the user is and under what circumstances they're using your application. If these tasks take long, you can always use the JavaFX concurrency framework to create separate threads for them. All right. All right, so let's now talk about the concurrent framework API provided by JavaFX. So this framework is, or this API is built on top of the Java concurrent package, right? And as a result, it is actually small on its own. It uses a lot of features already provided by Java concurrent package, which is a package that I believe was added in Java 5. So it's pretty old by modern standards. And this API has a few classes or a few components within it. The first is a worker interface, which is a generic interface, meaning it has a generic type. And this type of V, denoted by the capital letter V, is actually the return or the result of each individual task. Remember, the end goal is to be able to run simultaneous tasks, right? Such that we don't block the user interface. And each task obviously must have some kind of result. Or it might not, it might be void. If it is void, you use the class known as void as the generic type. But in most cases, it will have some kind of result. This result can be something as simple as a number, or as an integer, or a string, or something as complex as, let's say, a hash map data structure, right? So from this worker interface, you have different tasks, right? You have different abstract classes that represent different types of tasks that you can execute. There is the task, the service, and the scheduled service, right? So the task represents a one-shot task, something that you execute once and you never do it again in the application. Okay, if you want to do it again, you have to restart the entire application, but it is only executed once. You have something like a service, which can be reusable. You can execute it as many times as you want. And then you have a schedule service, which inherits from the service class, and the schedule service can be run repeatedly at specified intervals, right? So you can schedule it to run at a particular time. We will look at these different types of tasks and see how we can use them in correspondence to JavaFX UI features. All right, so let's now talk about the worker interface. So the worker interface provides sort of this definition of what a task should be in the JavaFX concurrency framework. And different types of tasks implement this interface, being the general description of what a task should be. And this worker interface is parameterized, meaning that it has a type, and this type is denoted by capital V, and it describes the return type of the result of the task itself, right? Think about it. If you want to execute a task in any application, it's most likely, not always, but most likely that task will have some sort of result, and that's what the capital V means. So there are different components to the worker interface. For example, you have what we call state transitions of the worker itself. Every task will go through different states, okay, and some of these and all these states are described by an enum, right? An enum that is called state, that is contained within the worker interface. And since different types of tasks, for example, the task, the service, and the scheduled task, which is the three different types of tasks that we'll look at, all these tasks implement the worker interface, and as such they also have this inner enum state, and the constants within the state enum are ready, scheduled, running, succeeded, cancelled, and failed. All right, so you have 6 different types of states that a worker can be in at any particular time, right? So you start with the ready state, and then once the task is prepared and ready, it can go to the scheduled state, right, describing what time it gets executed. And then once it is executed, it goes into the running state, and then from the running state it can branch off to 3 different types of states. It can either be cancelled, or it can succeeded state, or it can fail, right? And from these 3 final states of cancelled, succeeded, and failed, if it is a reusable task, for example, if it's a service or a scheduled task, which are the 2 types of reusable tasks, but the task itself is actually not reusable, right? But if it is a reusable task, it can loop back to the ready. So you'll probably have like maybe a button that says restart or try again, right? If this is not clear, we'll look at concrete examples that will make everything else clear. All right, so from here we'll look at an example, but before we do that, let's first talk about the properties of a worker itself, right? Describing a task. What kind of properties can you have access to? So within a worker will have a title, right? Self-explanatory, just the title of the worker or the title of the task itself. It will have a message, right? This is a simple text that you can pass to the user to let them know what is happening, what's happened with the task, has it succeeded, whatever, any particular message. And then you have the running property, which is a Boolean property that holds true or false, right? Is the task running or not? And then there is a state property, which returns the current state of the task. Is it in the ready state? Is it in the scheduled state? Is it in the running state? And is it in the cancelled, failed, or succeeded states? All right, that's what it means. And then you have progress, which describes the progress of that task. So the total, and then there's the work done and the total work, and the total work or work done and progress properties represent the progress of the task together, right? So the total work is the total amount of work to be done, right? The work done is the amount of work that has already been done, and the progress is obviously the ratio of the work done and the total work. And they usually describe, these are like numbers. Returns have double values, and they usually have -1 if their values are unknown. And then finally you have the value and the exception, right? The value represents the results of the task, and the exception properly represents the exception that is thrown during the processing of the task, if there is any exception, right? You might be trying to open a file, you might be trying to connect to some database, and if there's an exception that is thrown, that's where you get access to that property. All right, so to repeat it again, you have the title property, the message property, the running property, the state property, the progress property, the work done property, the total work property, the value, and then the exception, right? In other words, 9 properties that you can work with in any particular task. All right, so with that, we'll bring it to a close. Let's try a concrete example next, just doing a simple task that is now reusable, and then we'll see how we can use a service, which is a type of reusable task, and a scheduled service, which is a type of reusable task that can be scheduled to run at particular intervals of time. All right, so let's now look at an example. We're just going to create a simple task that will show all these properties that we've been talking about, right? The title, the message, the running, the state, total work, etc. And this is not a reusable task. Means that for as long as we have the application open, we can now reuse a task. We only use it once, and after that, it's done, right? We'll have to rerun the application if we want to run it again. All right, so to start off, a simple JavaFX application. Once again, I want to delete these default files, and from here we'll call this, let's say, main, and of course I want to remind Maven that this is our main class, our entry point. Rerun Maven and then close it, and I will add our run configuration, main com. All right, perfect. And now I want to extend application and do start and main launch args. Usually sometimes I forget the main method, but the application still runs. But you want to make sure that you add it as often as possible because it is necessary. And from here, I actually don't, we won't touch this for now. Let's just, what I want to create next is our UI, right? Because we have so many properties, so we'll have, say, we want to display these properties to the user through labels. We'll have many labels as well, right? So we just don't want to use a simple VBox. I want to use something a little bit more customizable. So to do that, I will create a class and then I'll call it worker UI, and this extends a grid pane, right? So this is sort of our custom grid pane, right? So, and I'll start with private final label call it the title, right? So we'll start with the title property of label, and I won't give it any value because we want to update that as a task is created and run. And I'll also create a label for message. All right, actually I have so many properties. Let me just I'll do let's see, I can copy this and paste as many as we'll need. All right, so after message we'll want a for the running, and then we'll want the state and the total work, and work done. All right, and then after this we want progress, and we'll be done with the labels. Now we want something different. Let's do final. But showing the progress through a label is not good. It's just showing a value that increments. Let's try something more exciting. Let's do a progress bar. All right, so we'll do a progress bar and call it simple progress bar, new progress bar. All right, and then we'll do a private final. We have two values remaining. That is the value, and we have two properties remaining with the value and the exception. For the value, I'll do a text area. Excuse me. I'll do a text area, and I'll call it value and new text area. All right, and for the exception, rather text area and perfect. All right, so after creating all our controls, I will create a constructor. All right, worker UI, and within this constructor, so let me just explain what we're trying to do. So we're creating these labels. At the end of the day, what we're trying to do is we're going to get the text properties of these labels and bind them to the properties of the task itself, right? Remember that the properties of the tasks are I'm not sure if I've said this, but the properties of the task are updated on the JavaFX application thread, right, which is where the scene graph is. And remember that you can only update the scene graph on the JavaFX application thread. That's the only thread in which you can update the scene graph. So since that the properties of the tasks themselves are updated on the same thread, it means we can use simple mechanisms like just binding the text properties of the labels and the controls to the properties of the task itself, making our life quite simple. So what this means is that we want to pass a worker, in other words a type of task, right, and the return value is an observable list that contains integer. Right, so I want to actually take this opportunity to also explain what the task will be doing. Right, it's something simple. We'll give the task a minimum value and a maximum value. These are numbers, and within that range it will find all the even numbers within that range. All right, so quite a simple task, and we'll also have to use some sort of trick to make sure that the task takes some time to run, so that we can see it, the properties develop and change throughout time. We don't want everything to happen at once. And from here I will do I'll do add UI, right? These are methods I haven't created yet, but I'll create them shortly. Bind to worker, right? This is where we bind the properties and when we pass it the worker. All right, so from here I want to do private void add UI. Okay, add UI, and here let's first do value. I wanna first make sure that we set the preferred column count, right? Column count to 20, and the value, and I want to set the preferred row count to, let's say, 4, but I want to do the same thing for a exception as well, right? So exception, set preferred column count to 20, and exception, set preferred row count. This time I want to do 5, but up here what I want to do is value and then set wrap text to true. All right, we want it, once it reaches the column length of 20, we want the text to be wrapped. In other words, create a new line as opposed to creating a slider to the invisible text that would be created otherwise. And here I will do this dot. Remember, this is a grid pane because we're extending grid pane, so we're working with a grid pane. And then we remember, in the grid pane we can set the properties of edge gap, right, meaning the horizontal gaps between the controls or the grids themselves, not the controls, the grids. And we can also set the V gap as well to 5. And then from here we'll do add row, right? Add row. From row 0 I want to add a new label, right? Say title, and I want to pass it the title value. All right, so 1 second, I want to copy this because we're going to be adding so many. Okay, I'm not sure how many, but just add as much as possible. All right, message, and here I want to do message as well. All right. And then message, we'll do running state, and this will be running state, and then 2, 3, this will be 4, this will be 5, this will be 6, and I think we'll actually need more than that. But for now, after the state, what do we have? I think we had, let's go up again, total work. Okay, total work, and we'll do total work as well. Here, work done, work done, and we'll do progress. Progress will be different because remember, we're using 2 controls. We're using the label to show the increasing numbers. Okay, so what is the progress? Maybe it's 5% now, it's 10%, it's 20% work done, it's 30%, 100%. We're showing both a progress bar, right? Sort of like similar to a download bar that shows how much you've downloaded if you're downloading something, and then the number itself. All right, so we'll need to show these side by side. To do that, we'll need to create a new h box, right? We'll give it a spacing of 2, and then I'll add a progress bar first, and then I'll add a progress label second. All right, and then we'll do add another row of 7, and then this will be value, and then we'll add the value text area and 8. Okay, this will be exception, and we'll have exception. So we have 8. Okay, we're starting from 0, so there's 9 properties. Okay, fine, perfect. After adding them to our UI, what I'll do is now we need to create this other method, which is private void bind to worker and observable list of integer, because we'll be having integers, and actually should have been worker here and worker. Perfect. And then what we'll do is we'll say for the title, so we start with the title. From the title we want the text property, right? After the text property, we'll bind it to worker dot, right, title property, right, which is a read-only string property. Perfect, no problem with that. And then we'll do the same thing for the message, and then we'll bind it to the worker dot message property. All right, and then after that we'll get the running property, we'll get the text property, and then we'll bind to the worker running property. But there will be a problem, because we remember that the running property is either true or false, which is a boolean value, and we'll be binding it to a string, so it won't work. We'll just use as string for it to return a string value version of that. And then there'll be state text property dot bind to worker dot state property. Again, it returns an enum or a constant of the state enum, which can be ready, running, scheduled, cancelled, failed, succeeded. So we'll also do as string. All right, so now we get on the tricky part. After the state, what do we have? So we have total work. Okay, after state we have total work. Now total work returns, so we'll do a text property first, bind. All right, so we want, remember that the total work can sort of be if we haven't started the task itself, told it what will be, what will be the maximum value for which we'll be searching, in which we'll be searching the even numbers. What will be the maximum value? You won't have any idea of what the total work is going to be, right? It can be unknown, or it can be a particular value. So we need a new mechanism to bind this. The way we do it, because we have many choices, we sort of have like if sort of things going on. The way you can do that through binding is that you do new when. Okay, so we pass it the first possible result. So when total work property dot is equal to -1, okay, -1 dot then, right? If it is equal to -1, then that means that it is unknown. So we want to bind it to the text value of unknown. Okay, and then after this I also do otherwise. If it is not unknown, what we'll do is we want to get the work dot total work total work property as string. All right, perfect. Once again, we're getting the total work property, and then we're asking ourselves, is it equal to -1? If it is, then bind it to the string value, which is a text property, bind it to the text unknown. In other words, its value will be unknown. Otherwise, if it is not equal to -1, meaning that the value is known, right, just bind it to the total work property as a string, right? This is sort of like a if statement. We're asking, is it equal to -1? If it is, okay, then it's unknown. Else, which means it's not equal to -1, which means it is known, then bind it to whatever value it actually is. All right, so we can also do work done dot text property bind, and we'll do new when, okay, when worker dot work done property is equal to -1. We'll do then unknown. Otherwise, worker dot work done dot as string. All right, so that's the work done. Now the progress. All right, so progress text property dot bind. So it is the same thing. New when worker dot progress property that is equal to -1, then it will be unknown. Otherwise, worker dot progress property, okay, this will be, we want to multiply by 100 because we're showing a percentage, okay, by 100 as string, and that will be, we also want to make sure we limit the decimal values. So I'm gonna do first percentage 2, and let's do 2 decimal values, and then progress bar dot, okay, progress property dot bind to the worker dot progress property. Okay, this is actually a simple one. And then what do we have? Value and exception. Okay, so value dot it will be text property because it's a text area, bind to worker dot value property as a string. Remember, the value property will be an observable list of integers. We want to put it as a string to simplify things. So exception text property dot bind to worker dot exception property as string. All right, perfect. Everything looks wonderful. Everything looks wonderful. So that should be all right. Let's see. Okay. All right. Okay. Perfect. Actually, I think we can remove the exception because we won't be getting exceptions in this example that we're doing, but you've seen how you can use it, or we can leave it there. All right, so we'll bring this video to close here because it's getting long. In the next section, we'll look at how to add the remaining features. Hello, welcome back. Now in this section, let's look at how to create the utility method that will actually check for even numbers, right? We want it to be a method that returns true or false if a particular given number is even. If it is even, it returns true. If it is odd, it returns false. All right. But before we do that, I was checking and I noticed that on our previous section where we created the modified grid pane or the worker UI class, on the exception, this won't work as we intend to. So remember, so for example, worker dot exception property, it will return an object property, right? Within this object, if you use its sort of as string or toString, it might return another modified message, which is not what we want. So we can use another way instead. What we'll do, let's say worker dot exception property, right? That add listener. We want to add listener to it. If it changes at any point, this will be OBS and old value. Then we'll have a new value, right? And what we want to check for is the new value if it is not equal to null, right? If it is not equal to null, what we'll do is we'll get exception. Or in other words, this exception, this one refers to the text area. All right, so exception dot set text to it will be set text to one second. Okay, worker. Okay, so it will be set text to rather than new value, not the worker, new value, and we get the message. Okay, remember the exception has this where you say, for example, if you create an exception, let me show you. If you do a try and then do catch, let's say interrupted exception e, let's call this object e, you can do e dot get message, right? Or s out e dot get message, and you get a more user-friendly message. Hopefully I didn't import any unnecessary stuff. And else we'll do exception dot set text to nothing. All right, as it is. All right, perfect. So now let's go back to what we intended to do in the first place, which is create our utility method, but I'll put it in a class, and I'll call this even util. Okay, this particular class, and then I'll do here is we'll just create a public static boolean, right? It returns a boolean is even. Is it even? And we pass it an integer of number, and then return num modulo 2 is it equal to 0, right? Is the remainder 0 if we divide by 2? If it is, that means it's an even number. If it's not, it's an odd number, and we return false. this expression will be false if it's not equal to 0. If it is equal to 0, it will be true, which is what is returned. Okay, so in the next section we'll look at how to create the actual task. Okay, we've created the user interface, the UI that will hold all our controls, and we've also created our utility method that will actually check if the number is even or odd. And then next we're going to create the task itself. All right, see you next. All right, so let's look at the task class now. So the task class is actually it's an abstract class that you have to extend if you want to create a concrete task that you can use in your application. But before that, there are certain, so within a task we said you have properties, and every task goes through phases. And of course, there are methods that allow you to manipulate these properties, and there's also event handlers that handle different phase transitions. So, for example, to update if you want to update the title property, there's an update title method. If you want to update value, there's an update value method. If you want to update the progress, there's an update progress method, etc., as well as for message. You will also have, like I said, event handlers that handle different state transitions. Like, for example, on cancelled, right, as the task being cancelled, on failed, on running, on scheduled, and on succeeded. If you want certain things to happen when a task succeeds, fails, or is running or cancelled, all the other transitions, right? You also have like so the task also has specific methods that get called, right, when something happens, like when a task has succeeded. You can override these methods to specify what happens, and that is much easier than setting the event handlers manually. So we'll look at an example to start. We're creating a task, which will be a class, and I'll call this even number task, right? And it extends the task class, right, which is again returns an observable list of integers. And there's a few methods that we have to override. So the one that we must override is a protected method, right, that returns, once again, the observable list, right, returns the result, and this method is called call. So, for example, once the error goes away, the remaining one is due to the return type. So before we go into this method, there's a few things that we first must create. We first have to create within this class. So for example, like we said before, the task will have a range of numbers, right? You have a starting number and an ending number, or in other words, a lower limit and an upper limit. And through within these limit numbers, within these two numbers, it'll search for even numbers, and then return an observable list of those even numbers. So we'll do final integer lower limit, and then private final integer upper limit. And I'll also do I'll also do I'll also have to create a private final long this time, right? I'll call this sleep millis, right, which is the time the time that that it will take application to sleep. Remember, because these are the task to search for even numbers is quite a simple one. Can be executed in an instant. We want to delay the execution by sleeping for some seconds, right? Doing the thread.sleep method. Then I want to create a even task. We'll pass it lower limit, and then we'll do int upper limit and long sleep millis. This dot lower limit goes to lower limit, and we'll do this dot upper limit equals to upper limit, and this dot sleep milliseconds. All right, so once we've done this, now we can go into our call method, right? So the first thing that I want to do is actually create the observable list that will hold the results. All right, so I'll call these results, and it will be an fxl collections of an observable array list. All right, once I've done this, next I want to do this dot update. Okay, we're using one of those update methods now. I want to update the title to say even number finder task. All right, that will be the simple title. And then I want to create this, so this count, right? This dot, I'll do upper limit minus this dot lower limit plus 1. What this count holds is the total work that has to be done. Remember, this is just a task that increments. So we're searching through a particular list of numbers and looking for those that are even, or rather a particular range of numbers and looking for those that are even. And of course, we know that the total work will be equivalent to the number of the numbers that are in that range, right? And in order to find that, we obviously take the upper limit, we subtract the lower limit, but we add 1. Why do we add 1? Take, for example, let's say the lower limit is 1. Okay, so we'll start from 1 and then we'll go up to 20. How many numbers do we have to search? It's actually 20 numbers, because we start from, we search 1 including 20, so that's 20 numbers. However, if you just do 20 minus 1, that is 19, right? Even though we're searching 20, even though we actually run through all those 20 numbers. So that's why we add 1 at the end. And then I'll do int counter, and this counter will hold the work to be done, right? So so here I can do, actually let me call it total work done. Okay, I made a mistake. It's not the work to be done, it's actually the work that has been done so far. Of course, it starts from 0. As soon as you create the task. So we'll then loop through different values. So int I equals to lower limit. We'll loop through all those values. I is less or equal to the upper limit. Okay, the less or equal to means that we include the upper limit as well. So I plus plus, and then in here, what I want to do first of all is check whether the task has been canceled. Okay, this is important. So if I check, so if I say this, okay, this is the task, remember, is canceled, right? If it has been canceled, there's no need to there's no need to go through all of that, right? The task has been cancelled. However, if it hasn't been cancelled, I want to first increment, not the counter, I want to first actually increment the work done by 1, right, each time. And I will also update the message, right? And I'll say checking checking if I is an even, why do I put in caps, is an even number, right? That's the message. But of course the value will always change as soon as we increment. So we'll start from 1. As soon as we increment, it will be it will go from 1 and then it goes to 2, means that the update message is changed, or rather the message is updated. And since this means that the property the message has changed in our UI, we did bind the text property of the message, right? We did bind it to the we did bind it to the worker message property. As soon as the message property of the worker changes, or the task, because the task is a type of worker, it will update this label containing the message, all right, letting the user know, okay, we're checking 1, we're checking 2, we're checking 3, we're checking 4, etc. And of course, I also want to sleep for some time. Okay, this is where we create the illusion of a long-running task. Okay, so we'll do this dot sleep milliseconds, and I want to catch an interrupted exception of E, and I want to first check if this is cancelled, at which point I'll just break out of that. Right, so this is in the okay, so we won't be updating the exception from here, the exception text area from here, because this isn't the actual task, right? This is just a piece of code that we add to show the illusion of a long-running task, but it is not the actual task, right? The actual task is what we do next, which is if, right, even num util dot is even I. In other words, if it returns true, results dot add, we need to add to the results I. Okay, and then we'll also do this dot update update value. Okay, and the value will be an FXL collections observable array list of results, and then we pass results in here. Okay, we can't just put update value I. Remember that the value or our return type is an observable list, which is why that's exactly what we need to update it with. And then what we'll do here after this is we'll also, by the way, update the progress too. Okay, so 2 ways we can update the progress. First, we need to provide it with the total work, I think. The work done, which is work done, and then we provide you the total work later. All right, I think this is correct. Yes, okay, perfect. And then after this, okay, we're gonna move out of, once you get a lot of curly braces, it's not hard to know. Okay, it's hard to know which is which, so we do return results. All right, perfect. Now there's a few methods that I need to also override. Okay, a few methods. One of those, protected, void, cancelled. Okay, these are the methods that are executed when a particular property is changed. So we first start with the super, and then I'll say update. What do I want to do is update the message and say task was cancelled. And then we'll do protected void failed, super dot failed, and then we'll do this dot update message, and then we'll do task failed, task, okay, task failed, and the other override will do succeeded. Okay. By the way, this is these are the three final possible states that a task can take. Remember, it starts from ready, and it is scheduled, and then it is run. Okay, it is running, and then it is either has either been cancelled, failed, or it has succeeded. All right. And if it is a reusable task, then it can be restarted again. So it can go from either of these three, either cancelled, failed, or succeeded, and then it will loop back. It will loop back all the way to ready, scheduled, and running again. We'll look at an example of a reusable task. So we'll do this update message, task succeeded. All right, perfect. So we're done with the task class. To go back to review it, it's just simple. We start with setting our limits, the range of the numbers. So this isn't a defined formula. Your task classes will look widely different depending on what you want to do. Some of those tasks you just need the call method. Others you need to, do all these things, depending on what kind of message you want to pass to the user. But it is important that we update these messages, because as you can imagine, it lets the user know what happened to a task. Has it failed? Has it cancelled? Has it succeeded? And at what stage? What is it currently doing? Right. So that's an important information piece that the user needs to know. And from here, then in the next part, we'll look at how to now deal with the main method, where we bring our UI and everything else together. All right, welcome back. Now in this section, we're going to look at the final piece of our example. So as we've created the UI for our work UI here, as you can imagine, we've added all the labels to keep track of all the properties of every of our task, but we haven't added any buttons to actually decide when to run the task. That's what we're gonna do here. I didn't want to add it there because that would just convolute things. So we'll start with button. Now we have the start button, which I'll call start btn. New button, I'll call this start. All right, and then I'll do not boolean button, and I'll call this cancel. So button, right, new button, cancel. Remember that we can start the task, we can cancel it, and of course we can also exit the entire application. All right, so we'll say exit. All right, so there's two things that the user can do to a task. they can start it and they can cancel it, right? A simple task. If it's a reusable task, then they can restart it. All right, so let's now try and see. Okay, so what we'll do is we'll first before I get into the start method, I want to do something. I want to first create a task, so I'll do even number task, right? Even number task, I'll call it task, simple as that, and new even number task. But remember that we have to pass it values now. So I want to start from 1 to 20, and I want to sleep for, let's say, 1,000 milliseconds each time. And then what I'll do is here I'll say start button dot set on action e. Okay, and then within in here I want to do a few things. So start, I want to create a thread. Okay, well, I'll call this bg background thread, which is a thread that will run our task. New thread, and then I'll pass it the task itself, okay, which is a runnable, by the way. And then I'll do background thread set daemon to true. We want to close it when we close our application as well. We want it to also close dot start here, and then cancel button set on action e is task dot not canceled but cancel, right? And then I'll do exit button that's set on action. We'll do stage dot close, and then down here I'll create a grid pane, and then I'll call this pane, and that will be a new worker UI. Okay, worker UI, new worker UI. I need to give it a worker, which is the task, right? So, and then we'll do an edge box to hold our buttons because they don't belong to the grid pane. We'll call it simple, rather box maybe. New edge box, and then maybe I want a spacing of 5, let's say. And then I'll add the start button, cancel button, and the exit button as well. All right, so and then I'll do border pane. Border pane, I'll call it root. This is what will hold both the edge box and the grid pane. So root dot set center, not exit button, but rather pane, and then root dot set bottom. We want our buttons at the bottom. All right, so, and then after this we'll do scene, create a new scene, and we'll pass it root. I want to pass it our values 500, 450, and then we'll do stage dot set scene. Well, okay, did I type there? Stage dot set scene, and we'll do stage dot show. Okay, perfect. I think we're done with everything. Let's run our example and see what we get. All right, perfect. Now we can see we have the title, we have the message, we have the running, which is false already because, okay, it's not running. And we have the state being ready. All right. Now I want you to watch, and the total work is unknown. Okay, so before we go into everything else, let's first go back. Okay, it has checked and he found that the total work is -1. He bound it to unknown, which means that its value is unknown. The same goes for work done as well as progress. We can see that the progress bar isn't doing much. The value is null. The exception is nothing, because remember we set the exception to nothing. Now, if I click the start method, it will start the task itself. The running will go to true, and the ready will change, right, to running. And then the unknown, the total work I believe will be 20, and then the work done will continue to change, as well as the progress. So, and then of course these progress will start to fill out. Let's run it and see what happens. Okay, running true. We can see the message has been updated. The task has also been updated. The total work is 20 and the work done is 10. And we can see that the percentage is changing, as well as our results, or the value, are also changing. Okay. All right, so perfectly, right? The even numbers, these are the even numbers between 1 and 20. And it also checked 20, by the way. Okay, like I said before. So the work done now matches the total work 100%. The state has changed to succeeded, and running is back to false. The message is task succeeded, like we did override it here. Task has succeeded, and the title is what the title is. All right, so now, because remember we said that this task class, when you use this task class, right, it means that you created a one-time or a one-shot task, which you can only run once for as long as the application is open. If I try to click start again, nothing happens. If I click cancel, nothing happens. If I want to rerun it, I'll click exit. So let's try to rerun the whole application and then click to cancel before the task actually finishes. Let's say we click when it gets halfway, 50%. So we start with all right, so we start 20%, 25, be ready when it reaches 50%. So 45, 50, I click cancel. Okay, the task has been canceled. That's a state. False, task was canceled. All right, even number, and these are the only results that we have so far. I cannot click start again. Okay, I can't restart it. This is what it means. Once you've started it, if it fails, if it is cancelled, if it succeeds, that's it. You can now go back. You can now go back into the tree. Remember, we start with ready, scheduled, running, and then it branches out into 3 possibilities. Is it cancelled, failed, or succeeded? And then from these 3 possibilities, if it's a reusable task, right, which means we'll be using a service class instead of a task class, it can look back, go back to ready when you click start again. Okay, that's the example that we'll look at in the next section, but for now we'll bring this to a close. All right, so let's look at what we would call a service, which is a type of a worker. Right, it's a type of task as well. Rather, it's a type of worker, not just a type of task, because task is a type of worker as well. But the service, the difference between a service and just a simple task is that the service can be reused. Right? It can be restarted. It can be reset to 0, even though it's running, it's executing. It can be reset. It can be restarted. It can be reused. All right. So the service class also implements the worker interface, and it encapsulates a task within itself. Right. So we won't actually need to redo this. We already have the task. We just need to encapsulate this, even num task inside a service, or encapsulate with a service such that we can reuse it. All right. So how do we do that? We'll go into here, and we'll change a few things. So first, what I'll do is excuse me. What I'll do is I need to first add another button, and that button is called reset. It's reset btn new button. Say reset. Now I could also add another one called restart, but we can use the start method to serve the roles of two buttons. I'll show you how. So first I need to make sure that I do reset btn. I add it here, and in here I'll do a few things first. So I need to first create the service. So what I'll do is I'll say service, right? JavaFX.concurrent, and service, remember, okay, it returns also an observable list of integers. Okay, we're not changing things. And I'll call this a service, simple service new. Okay, actually I need to remove this. This is not necessary. I just need, yeah, that's more like it. And it has this create task method, which is our interest here. Return, then I just need to return it a task, right? Quite as simple as that. So now I've created the task. Okay, we'll have a few errors here that we'll need to change. So within the 1 second, so we'll do, I want to first remove all of this. For the service, we will need to create these threads. So actually I'll do once, what I need to do is create a boolean value, boolean, not the capital boolean, but the small boolean, started equals to false. Okay, because we need to keep track of whether has it been started or restarted and stuff like that. So if it has been started, right, if it has been started, what we need to do is service dot start. Okay, so started here starts with false. If it is false, we need to start the service. If it is not false, what we need to do is service not okay, excuse me, it should be start here and restart here. Okay, and then we'll do started. We should name this once started. That's better. Okay, once started is false, we restart. If it is true, there has been one start, then if it is false, rather we start the task. So once restarted equals to true, we change it here, and we'll do the start button we'll change the text on the start button. This is what I meant, that it can serve as a restart button as well. Okay, so here we'll do on the cancel, I'll do service.cancel, and here I just need to pass it the service class. Let's see, are all our errors gone? Not they're not. Okay, here, okay, we need to add a semicolon here. I believe everything is ready. Let's start. Okay, so we have the start method, the start button, and a reset. So what we'll start with, let's first create, click this start. You can see that it goes to restart. Okay, so we go, let's maybe go to 50% once again and click restart again. Okay, it goes back to the beginning. Okay, and it is in running. I can do cancel, which has been canceled, restart, okay, and then start again. And I can do I can first click cancel, I do reset. Okay, I haven't sorry I haven't put the reset listener. Okay, it's just there, but it's useless. Let's do the reset. So reset button dot set on action, and e dot service dot reset. Okay, so let's run again. You can do start. Okay, it's going up. Reset. Okay, this, it throws an exception because we can't reset a running task. What we need to do, however, is actually what we need to do is first cancel it or let it end. So we do start. Okay, then I can do cancel. If I do reset, it goes back to what it was before, and I can restart it again. Okay, and cancel and reset. All right, so to avoid these errors, you might want to be able to add limitations. Let's say, for example, if the task is not in the canceled state, the reset button is deactivated and things like that. These are simple functionalities that you can add yourself. Instead, or maybe instead of doing the stage dot close, what we can do is platform dot exit. Okay, same thing. All right, perfect. Now we'll bring this video to a close. See you in the next section. All right, so in this section, we're going to talk about the scheduled service. So the scheduled service, first of all, is a service which automatically restarts. Right? Now, this is important because there's a few use cases. So suppose you have an application maybe that checks the score of a particular game at specified intervals, right? Let's say maybe it checks the score of a game at every 10 minutes, or maybe it updates the weather report every 5 hours or something like that. You obviously don't want to do this manually. You want something that can do it automatically, and to do that, you create what we call a scheduled service. So to create it, it's quite simple. What I'll do is I'll come here and just do scheduled. So we'll do scheduled service first. which we put here, and then I'll come in and do scheduled service. All right, perfect. So in the imports we have warning, we need to remove the service, and right, it's quite as simple as this, honestly. It will use the same task. Okay, and the few properties that you can change. So first of all, it will keep track of the last value, right? Because value changes. You can keep track of the last value, which you can get. You can also specify what we call a delay, which is one of the properties that are added that you don't have in the service or that you don't have in the task. And that delay is a duration. And it specifies the delay between the service, when the service is started and when it begins running. So the service stays in the scheduled state for a specified amount of time, depending on whether you want that or not. And there is the period, which is, in my opinion, more important. That is another property. And this and the period specifies, right, it specifies the minimum amount of time between the last run and the next run. Okay, so this is the interval that I was talking about. And to give you an example, but before we do that, there's also one important property, which is the restart on failure, right? It can be true or false. This property is important because so you can do, let's say, restart, or rather set restart on failure, which if you set to true, when the task fails, you can restart. So how many times can you restart? You might want to put an end to say, okay, we want to try, if it fails, we want to try maybe 3 times or 5 or 10 times, right? Which means you can also, right, set maximum failure count, and you can specify, say, okay, if the task fails let's say 5 times, don't rerun it. Okay, we'll try to run the task a number of times. If it fails 5 times, stop, don't run it again. Okay, so but how can we rerun it in specified intervals of time? So what we can do is say, maybe service, we want it to run every we'll do set period, and we want it to run every, let's say, 5 seconds, every 5 seconds. Okay, so we'll do duration. Okay, we'll use the till duration, seconds. Okay, we're saying 5 seconds. We want it to run every 5 seconds. And of course, I've also changed the milliseconds to 100, just milliseconds. We don't want 1,000. That will take a long time. Now, if I rerun the application, I can click start. Okay, the task ends, it goes into scheduled, you wait 5 seconds and rerun again. So back to scheduled, rerun again, back to scheduled. Okay, as you can see, the state remains true, right? It doesn't change, the state remains true. And then I can cancel it. If I cancel it, it won't run again. And then of course I can reset it and run again. 1, 2, 3, 4, 5, boom. Okay, 1, 2, 3, 4, 5, it runs again. Okay, you get the idea. That's what we mean by period. And of course you can specify to be significantly more than this, but then the question is, how many times will it run? Is it infinite number of times? Actually, the maximum number of times that it can run is equivalent to the maximum integer that you have. So that will be int, let's say max value. Let's look at what that integer. Okay, I'm just gonna print it in the standard output. Okay, this is that number. Okay, that's the number. And of course, 5, boom. It will run this many times, which is ridiculously large, and it's going to take a ridiculously long time. But you can also obviously change it by saying the cumulative period or the maximum cumulative period, right? You can do service.set maximum cumulative period, and it will specify the maximum period that it can run. It can rerun. Okay, so with that, we'll bring the scheduled service to an end, as well as this whole section about concurrency. What I wanted to show you in general was provide a way for JavaFX. If you're writing JavaFX applications, for the most part, when you want to run some sort of concurrent task or concurrent function, is when you want to maybe connect to a database, run some long-running task, or connect to some sort of remote server, or maybe connect to the internet. And these tasks aren't really complicated. It's just that the concurrent framework will just provide a neat way for you to be able to achieve this by just creating a simple task like this one, and it might say within this call method you might connect to some remote server, extract some data, and then use that data to update the user interface or the UI, or maybe from there use that data to create another task, or maybe connect to your database and update your database as well. All right, so with the final project that we'll do, we'll also find a way to utilize these features as well. Okay, that will bring this to an end. See you in the next section.